Alright guys, let's see how we can solve question 61 from the first chapter of Mechanics of Materials. This is going to be a follow-up question to the previous video. And for the assembly and loading of the previous problem, we need to determine A, the average shearing stress in the pin at point C, and in the B part, we need to find the average bearing stress at C in member BC, and in the C part, we need to find the average bearing stress at B in member BC. So what we did in the previous question was that we basically tried to draw the free body diagram for point B, and what we end up was this triangle where we had the sum of each of these two forces equal to the third vector in the opposite direction, obviously, to cancel each other out. So this was our FAB, that's 10 kips, and this was FBC, and we figured that the member AB was in tension and member BC was in compression. So we just did law of sines and we found FBC, which was 8.966 kips based on the law of sines. And in this video, we need to, first of all, in the A part, find the average shearing stress in C. So we are looking for the shearing stress, which is going to be FBC over the area, and the area that we have. So the pin is connected to two supports, and we're going to have two of these circles as our shearing area if this is our pin, and these are created by the supports. So we have two different areas in here, so I'm just going to put it by 2A, and we already have the force. We just have to find this area in here, which is the area of the circle that we have. We know the diameter for all the circles are point A. That was a given in the previous question. So the area would be pi over 4 times the diameter squared, which was 0.8 squared. So we should be able to find the area in here. So FBC is basically 8966 kips, and we're gonna have 2 times pi over 4 times 0.64. So we just have to calculate this to get the final answer. So 8.966 divided by pi divided by 2 times 0.64. So this is going to give us 8.919, and we have kips over inches squared, which is going to give us KSI. So that was the A part of the question. The B part, we need to find the average bearing stress at C in member BC. So we talked about the bearing stress in the previous videos, and basically we can find the bearing stress by dividing the load that we have, or the force that we can see in here, which is the FBC, by the area of the rectangle representing the projection of the pin or bolt or whatever we have on the plate section. So in here, so let me show that area in a like simple example here. So if we just have this area, if we have like this plate in here, the area that we are talking in here would be the area of this rectangle, which is the projection of the bolt on the plate. So basically the area would be the diameter, or D in here, times the thickness, T. So the area would be D times T. We're gonna have same story here. So we have that bolt at point C. So the projection would be like an area that we have in here, very similar to the other question. So again, we're gonna have the diameter D times the thickness. The thickness of this plate is 0.5. We have it in here. So it will be D times T. So our D is 0.8 and T would be 0.5. And that's the area that we are dealing with in here for the bearing stress. So I'm just going to show it with FBC over another area. I'm just going to show this A prime just to differentiate with the previous one. So we have the same force, but we're still in BC 966 kips over, we're going to have the area of the rectangle, which was basically 0.5 times point A. This was our T and this was our diameter. So let's just calculate this. So just gonna do 0.5 times point A. So this is gonna be 22.415, same unit, KSI, and that was the B part of the question. And the C part, we need to find the average bearing stress at point B. So the difference that we have at A and B is that the member BC at point B, the area would be a little bit different because we have two parts of this member engaging with that pin. So everything is the same because we're gonna have the same thickness. All of them are 0.5 and we have same diameter for the bead. But since we have two parts, one in here and one in here, we just have to multiply our area by 2. So the bearing stress in this part would be again FBC. And since we're gonna have twice area of the previous part, we're just gonna put it 2A prime. And basically we're dividing the answer that we found by 2. So we're just gonna divide this by 2, which is gonna be 11.208. Okay, sorry. So yeah, that's pretty much everything for this question. Hope everything was clear. This was a good question to recap all of those bearing stress and all the areas that we have in this chapter. You guys take care. I'll see you in the next video. Have a good one.